This time on Captain Chaos Laboratory, we're working on the Department 56 Halloween dance. This is how I pulled it out of the box. Well, this was sitting on top of it, but I pulled that off so I could look inside to make sure there's nothing in there. But there you go, Halloween dance. It's from Department 56. It's probably older than dirt. Yeah, there's no date on here. Anyhow, I bought this to either use as parts or fix and give away or whatever. It's actually mine. And I pulled it out of the box just a minute ago, and it's a 120 volt version with the switch in line. So you have to be careful poking around in here because it's mains. So if I plug her in, click, and then nothing, honey. So I did check the fuse in here. There's a fuse right in there. You can slide this. There you go. So it's not so much glare from the camera. So that fuse is good. So it's either a bad board, which this does have, two circuit boards, right here and right here, or the motor is bad and it's causing it to short everything out. So it's unplugged. So the first thing I'm going to do is I'm going to cut one of the motor wires. The motor is 120 volts. The lighting and speaker is probably 12. That's what this transformer is for. So it's unplugged. I'm just going to reach in here, right where it connects to the motor, and snip. So this red wire I'm going to pull out and away, because the end of that wire, once I plug it in, can potentially have full mains power, approximately 120 volts. So plugged in, and still nothing. So it's unplugged. Now we're gonna take the deck off, move the characters that were loose in the box, and see how this thing comes apart. Apparently it comes apart underneath the violin, or the jester with the violin, violinist. Okay, or does it just pry off? One of the two. It might just pry off the shaft of the motor. Need something bigger. That's not bigger. That's bigger. Okay, so it's just pressed on, and the violinist, or even though, that's a violin. There's a little screw right there to unscrew said violinist. And we got 3 screws right here. I think the reason this is in pieces is somebody was working on it before they took it to the thrift store I bought it from. Because it's in pieces and this screw is stripped out. And I need to see if I can get it out. There we go. So I'm going to set this one off way out to the side so I know how to replace it. So the worst case is this will just be a piece I bought for parts. I think this brass piece was supposed to stay pressed into the bottom since it's fatter than the hole there. So here's the motor. It's 120 volt AC, 3.7 watt, 6 RPM CCW motor. So the power comes in. And I have no clue what they did when they resoldered all this, because They're sending mains voltage to a 3-volt transformer. So, wow. I think it's got 3 circuit boards. Okay. Well, that is interesting. I have no idea how they did this, but somebody screwed this up badly. Probably fried the entire unit. So, again, these white wires here is 120 volts. This red wire was attached to the motor. This black wire is attached to the relay and to the transformer, which the transformer should be attached to. This is a 3-volt DC relay. Trying to send 120 volts to it. I am surprised this thing isn't black and exploded. So whoever was in here didn't understand electricity and how it functions. All the circuitry has to be on the output of this transformer. So I don't even know if the transformer works being wired wrong. It might be fried as well. But we are going to see if this is salvageable or if it's going to turn into parts. Let me get rid of this black wire, so that way this relay is not hooked up. And this motor, let's turn on the soldering iron here. Quick. They also soldered the wires here and here. So I'm going to take this, I'm going to solder this here, so that way we have 120 volts going right to that motor to see if it spins. I have no idea what this was for. Unless this was connected to... No. I guess we'll figure it out, but we got... We're going to have to see where the inputs are. We're going to have to pull the circuitry off. But first things first, I'm going to solder this to the motor, which will give the motor 120 volts. We'll see if the motor actually works. And they're missing the screws for the motor, because this motor was screwed in at one point. Man, I have to move my phone so it quits making so much noise. This is a lot of heat dissipation between the wires and the copper flange for the motor, so it has to be a longer duration of holding to get it all to melt, which of course these wires then get really hot. So I'm going to need some little metal fingers here to hold this so I can solder this on. There we go. So let's get the motor back in. So there's still stands right here that it sits in, but the stands have, the holes are actually threaded. So there's probably some flat top screws that went in there to keep that so it doesn't bounce around, because technically this is the only thing that holds that disc on. Let's see if we can remove this transformer before we plug it in so I can see what it's rated for. I believe it's going to be rated for probably 3 volts. Only reason I say that is because of this, but it could be higher. Output is 3 volts DC. Input 120 volts, output 3 volts at 400 milliamps, or just under a half an amp total. So we'll also test the output of the circuit board, or the input of the circuit board, to see if this thing actually is sending the correct voltage to the board. I mean, I'm assuming it's all wired in the right spots, but I'm gonna guess it's probably all wrong. Let's see, what does it say? What does it say? The board's not labeled with anything more than the symbols, but it doesn't say which is negative and which is positive. It says that there is a diode missing, but I don't think it ever had one. I mean, it might have. There's a really horrible solder hole there where there's a diode right here. There's the symbol. So that sends power to this board. This board probably has the blob chip on the bottom. It does. Which may no longer function because of the, bad power issue. I need to get the hot glue off. And the hot glue is holding the track on, because the track is no longer attached to the circuit board. So that's good. So, whatever this circuit board sent power to this relay, the track of the board is still attached to the wire. So the circuit board no longer has a path for electricity to flow. So right here, you can kind of see it right there. That big square compared to the wire is the actual track on the circuit board. So the red wires go in, the red and black wire, sorry, go in, and they are soldered to the center of the board. I need more slack, so let's pop this board off. So the blue wire that's broke is the speaker. That's why there's no sound. Also, I'm sure the miswiring of the incoming power doesn't help. So let's get that broke free. That way we can flip all this over. There you go. It smells funny. That's never a good sign. So, black and red. Red is soldered here, which then jumps over to the lights. Black is soldered here, which that track goes to the blob chip. So does red. And then we have two white wires coming off. One goes up to the lights, and the other one goes to this relay. And I have no idea what the output of the relay is for. I really don't. I know it doesn't go to this, because this is 120 volts, and this is a 3-volt relay. It can only handle 2 amps. So we got transistors for the lighting, which is why all the lighting comes off here. So I'm sure the lights flash. So these transistors help create the flash patterns. The resistors look okay, the capacitors look okay, both that one and that one. That diode looks fine, meaning I don't see any burns, explosions, or bulges. That diode looks okay, that capacitor looks okay, these two resistors look okay. One thing I see that's bad, besides the wiring, is we got a bad track due to it not adhering properly and it's torn. We have some bad solder joints, but as long as there's a connection, they should be okay for testing. All right. It's kind of looking like if you have this and you need some spare parts, it might have some. I don't think this is going to work. I'm going to go turn it on. Let me go plug her back in and throw away all this glue. Motor spinning. Just the. Nah, I really can't prove it. It'll hit the circuit board. But the motor is turning. What I'll do is, that way you can see, none of the lights are on. There you go. You see it turning. All right, let's do some voltage testing. So everything I test should be right around 3 volts, give or take a little because of free flow. So it might be 4, it might be 3.5. I need to tip it just a little bit so I can see the meter, because from my angle, all I see is the lights that are over here. So that doesn't help me. I need some taller. Let's try a bigger battery. Hey, that helps. And you can still see it on camera. Good. So, first things first, let's see if we can test the output of that transformer. And power for a second. So either not getting a good connection or the transformer smoked. I think the transformer smoked. I'm not getting any output. This is why you have to be careful. So now it's on AC. 121. So definitely, when you're poking around here, you don't want to touch those connections. So that's why I always say if you have one that's 120 volt mains, or even 240 if you live overseas, be very wary of the ones that have a full power motor, because there's nothing protecting you from putting your hand across it, and well, it's gonna affect the rest of your day, I guarantee that. Especially 240. Make you all tingly on the inside for a while. So let's try, I'm just gonna see if I can poke into this a little. Yeah, I'm getting nothing out of that transformer. So I think the transformer's burned up from being wired wrong. Let's turn it off. There we go. So I don't know which polarity is which. I'm going to just mark one wire with black, because what I'm going to do is I'm going to cut it out of the circuit and test the transformer all by its lonesome for two reasons. One, I can test it by its lonesome, and two, I can apply 3 volts directly to that that connection. Bear with me. I gotta take this. Sorry. Okay, I'm back. Sorry about that. So, I turned off the meter to save on power. So I got the 2 wires stripped, and the reason I wanted to do it this way is, one, I can test it without going through the circuitry in case there's a draw, a short, something like that. And then the second reason is I can take my power supply and hook 3 volts right up to the circuit board all by itself, without using this if this is bad, to see if like lights come on, as an example. I know the speaker won't because the track's ripped free from the circuit board, so I'm not too worried about the speaker at the moment. I am going to move it so it doesn't arc the circuit board. So let's turn her back on and see if we get any power out of this transformer. Power's on, motor's spinning. There's the meter. So we have one there, and I need to move it so I can see it too. So the transformer is bad. So it's not putting out 3 volts DC. Now I'm going to switch to AC and see if maybe the rectifier inside died. Yeah. So that's the problem. So I'm getting 6 volts DC or AC coming out of it. So inside here, it should change it over to DC, either using a rectifier or the way the coils are wound. And whatever they use to change it to DC has failed. And that's why I'm getting 0 volts DC. But I see the circuit board also has 4 diodes. Those 4 diodes in this order, the way they have it run, converts AC to DC. So I don't know if this is mislabeled or if it's bad. But it is putting out 6 volts approximately. AC, not DC like it actually is labeled for. So let's turn this back off. And let's turn on this. Let's set it for 3 volts. Oops, that's too high. Go down. Too low. There we go. 3.1. It's bouncing. Just so you can see, red on the red, black on the black. 3.175. So we're getting 3 volts DC. Now, since we have basically isolated this from everything, let's put the power on the board. The one thing I don't know is which way is which. Technically, if this is a full bridge rectifier, it should be fine, even if it's reverse polarity. So I'm getting no power draw on the machine. So I have a phony feeling something has exploded internally. So, let's test the next thing. This is the outgoing wires. I'm assuming red is hot and black is not. So that's the red. That's the black. And I got no voltage. There we go. I got 1.9 volts coming out of this circuit board. So, I may have lost a diode. Yeah, 1.9. The red was. So the rectifier is working, it's just the voltage drop is huge. I know diodes will drop voltage. I don't know if it's supposed to drop it by a full volt. I would assume it only drop it to maybe 2 point something. Let's try this. I'm going to hook this back up. I'm thinking I'm going to pump up the volume here. So, most power supplies, when it says, like the Lemax, you've probably seen in other videos if you watched them, they say it's a 4.5 volt power supply, but with no load or a light load, they put out like 5 as an example. So, let's crank it up a little. Let's go 3.5 volts and see if the output has gone up enough maybe to energize some of this. I still have nothing lighting up on this end. Alright, so now let's check the outputs. See if we're getting something better. So we still got a 1.3 volt drop. So from 3.5 and change, we're getting 2.2 and change. 2.2 will generally turn on orange lights, green lights, red lights. And I still have no lights. So, let's see if we got anything coming out of this relay board. I'm going to assume again black is hot. Oh, sorry, red is hot and black is not. That's pretty much nothing. It's half a volt or less. Okay. I think this thing got smoked. Either it was smoked before it was rewired or it got smoked after it was rewired. One of the two. Okay, so we got 2 there. Let's see what the lighting has. So, the white wire, I think, is the negative. And the yellow and red wire, I think, is the positives. Or it's 1 and 1. Let's see, what do we got here? So I do have power going through the yellow wires. And I have nothing with the white. And where's that red wire? Okay, the red wire's hot. 1 yellow and 1 red's hot. And the white, for some reason, has nothing on it. So I'm getting 2.2 volts up to these LEDs on the yellow. And the yellow wire goes right here, and right here only. Which is an off-on switch. Interesting. There's no paperwork, so I have no idea how this thing was supposed to work originally. But pressing the switch, no lights. You should probably zoom out so you can actually see poking things. I just realized it's not. When I press the switch, it shorts out the wire, which is what it should do. I'm going to zoom out so you can see that I'm playing with the circuit board. I didn't realize it was off camera. So these two yellow wires go right here to a switch, and then the red wire and the white wire, they go to the pumpkin here, the pumpkin here, the pumpkin here, and the pumpkin here. So I got 4 pumpkins that are supposed to light up, and no matter what I do, they're not lighting up. And that's because I don't have power going to them. So the red wire moves all the way to right here, and the white wire, which is spliced, so is the red wire, that white wire goes to the bottom edge. So red wire is hot, white wire is not. So I'm getting 0 volts. I think the relay was supposed to be attached to that switch. Now I'm getting 2 volts. Yet none of the lights are working. So, glue was used as an insulator on these twisted wires. What I want to do is maybe the LEDs are burned out because, you know, it was wired wrong and might have sent 120 volts to the LEDs, which you're not going to like that, just so you know. I'm going to just wire the LEDs directly. So since they're not soldered, this one is, that one wasn't. I'm going to put the power there, because that's the power, and the negative here, but I need to turn the power down because any LED 3.5 volts is a little high for most of them on these pieces. There we go. So I'm at 2.2 volts, no draw, and nothing is lighting up. So like I said, this shows that there's 4 LEDs. There's one there, one here, and one here, which line up with the 4 pumpkins that are a slightly different style than like these pumpkins and squash that are here. Maybe they're a higher power, so we're gonna, there we go. Now they're working, so it does require the full voltage. Apparently, they're flashing LEDs. So there's either they're flashing LEDs in the sense that they flash, which is possible, or there's another little circuit board inside here. I'm going to turn off the light so you can see it. I'll turn off the other light too. There we go. So that's actually pretty cool. If you're epileptic, it may not be. Oh, sorry, lights are coming back. There we go. Alright, so the lights do work. It requires the full 3 volts. The board is only sending the lights 2 volts, 1.9 at 3 volts, or 2.2 volts at 3.5 volts. So the board is not sending the power like it's supposed to. So I got a massive voltage drop from the AC filter board, putting power directly here isn't sending enough power to this. The relay, I'm going to assume, again, it is for the switch. But the switch is these yellow wires here, and they're not cut. So they may have been resoldered in the wrong spot, because one solder joint for this yellow wire here is new on both ends, and this white wire, that's original, that's a resolder. I don't have a schematic. They don't give you schematics. This is probably way too old for them to do that anyhow. But the point is there's definitely something wrong. And I have a funny feeling that something in here got burnt badly when the mains voltage was sent through, partly through this. Technically, it should have exploded. Because this is only rated for 10 volts. This is only rated for 3 volts. This one's rated for 16 volts. And I'm talking the capacitors. I'm sure the resistors are probably close to that. I really wish I knew where this actually went. But I know it didn't connect over here to the main voltage side. That I can guarantee. But I do like the way these flash. What I'm going to do now is I'm going to reconnect it, and I'm going to just put the 3 volts into this board directly right here. Or I'm going to try to, let's put it that way, because the incoming voltage is right here. Right there. Like that. Just twist this back together. So it's at 3.1, 3.2 again, it's bouncing. And because the negative is in the middle of the board, I'm going to have to actually hold it. I can't just clamp it on. So, and if I press the button, well, I pressed the button and the lights work. And if I press the button again, the lights quit. Nope, they just stay on. I think I'm just losing connection. Yeah, I'm just losing connection on the board. Okay. So I'm wondering if I can try and solder this track back. It's going to be a treat. And see if the sound works. For stuff like this, I highly recommend having the jeweler's type magnifiers. So what I'm doing is I'm scraping the green coating off of the circuit board on the track that's broken, so I can expose the track below the green. So the green is just a coating to protect it from bugs, moisture, dirt, dust, grime, grease, so on and so forth. The only concern I have with doing this is the gap between the blob chip and the track is maybe 1 millimeter, which means that it could overheat the chip and crack it because the soldering iron's hot. So I've scratched away the green coating. Now I am, to reduce the amount of time I need to touch this circuit board with heat, and I'm going to flux it. So I got my flux pen. I'm going to put a little flux on her right there. And I'm also going to flux the wire. So I want to make this as fast as possible for soldering, so that way the heat transfer is very minimal. Because I really hope the blob chip's still intact. Because the other option is I can make this a dual power, like some of the buildings where there's 3 volts coming out and 120 coming out, or I can try and find another transformer since this one's bad, or I can try and rebuild this rectifier, or, I mean, there's a lot of ors, but we don't have a boat. So let's pretend this. Once this gets up to temperature, anytime I want to get up to temperature, there we go. Okay, so that's good. Let's move this over. This is the tricky one. And here we go. Let's turn that. And all right. Let's wet the tip and see if we can do this. Quick touch. There we go. So one of two things, either it's going to work or it's not. And if it doesn't work, it's either I just got it too hot and damaged the chip, or it was damaged from the miswiring. Don't know. But. All right, power to the people. Let's see, so hot goes right there, and my negative juice. So hey, we're getting there. All right, so we now have confirmation that the sound in the blob chip is intact. The lights were flashing. You heard the music, I hope, the monster mash. So now we're stuck at the point where, is the transformer my problem or is this my problem? So I'm going to go ahead and solder the transformer back on, and we're going to try the mains again. I'm thinking that this switch may be obsolete, meaning that I'm not going to be able to wire it in because I don't know how it's wired in with this relay board. I don't want to screw it up. If I can make it work where you turn on this switch here, come in the camera, it's so tight because the plug is so far, and it turns everything on, then who cares about the push button on the front? Just cut this little board out, get it out of the way, and we'll go from there. So, and I'm sorry for how long this video is. It's probably boring for most everybody, but this is what I do off camera when I film some of these long videos. I pause the camera and I sit here and do stuff like this, trying to diagnose where or what the problem is and if it's repairable. Not all of them are, but I figure, hey, let's just go all the way with this one and see if we can make it work. And maybe the reason it's not connecting good enough is these solder joints are horrible. You know, maybe that's the whole problem. I realized I put my flux pan away. Wanted to flux these to help break this crap out. So the one on the right is going to be the black stripe, And the one on the left is going to be the red, but just to make sure, I'm going to put black on the edge of the circuit board so I remember. So when you desolder, you should add fresh solder. It helps heat transfer, and the new solder gets into the old solder and helps it break apart. Just so you know, that's the reason I do it. I don't do it all the time. Sometimes the flux will do it too, but that's the principle behind soldering old wire to pull it out, is to allow heat transfer and penetration. So there's the one old wire. And two old wire. Clean that. Solder pads are horrible. I think the person who owned this used too much heat, or they applied it too long. I'm not sure. But a lot of the solder joints are damaged. These look like cold solder joints, but the pads are separating, so I think they were maybe lead free. I like using lead solder. And these cheap wires are going to need to be fluxed. Well, that one took it. This one's not. There we go. So you shouldn't breathe the vapors because there is lead in this solder, and blah, blah, blah. Lead-free solder sucks. So anybody that does soldering can tell you that lead-free solder sucks. You get a lot of cold solder joints. You don't get the penetration you need for the heat, and it also takes a hotter temperature. So, and the lead in lead solder is so minute that you could solder your whole life and probably never get lead poisoning from it. So what I'm hoping is, because the free float on that thing is almost 6 volts, that'll overpower the voltage drop that we're getting, and that overpowered voltage drop will allow it to work right. So I stripped too much of the wire off, and this one's soldered lower than I thought, so I'm just going to cut off the end so that way it doesn't touch anything at arc. Alright, so we have the incoming power, comes off the motor because the motor is 120, and then the incoming power, I'm just going to cut that off so I don't rub up against it because that would be 120 volts, and I don't feel like getting shocked today. Which then branches off to the 120 in and technically 3 volts DC out, which is reading at almost 6 volts AC. We have a full bridge rectifier right here on the board, which might be because this is mislabeled, or it's a backup in case this doesn't work like it's supposed to, which then feeds this board, which we know the speaker works, which then feeds this board, which does absolutely freaking nothing, and we know the motor turns. So if turning it on turns on the lights and the sound, I'm going to call it good, and I'm going to remove this board. I'm going to put screws in this and put this thing back together. Here we go. Yeah, the button doesn't do anything. The lights are working. So yes, I'm going to turn it off because there's no volume. So yes, this being 6 volts free float, it overpowers the bog caused by the diodes. All diodes have a voltage drop, which allows the power coming out to be high enough, being 3 volts minimum, because these lights didn't even turn on until I hit 2.8 on my machine over there to make them flash. So, and then this rectifier is working because it's DC, So what a rectifier does is, it's called the full bridge rectifier because we've got 4 diodes. There's a schematic. You can Google full bridge rectifier. You'll see the schematic. It looks like a diamond generally. What it does is it takes AC in, because AC is 2 alternating sine waves that do this, and it converts it into a square wave DC on average. It's not a smooth wave. If you put it on a graph or a oscilloscope, you'll see it. This does that. That's why this is called a graphical tester. If I took the DC, it'll show you the sine wave that's coming out. I don't really care if it's straight line DC or if it's pulsed, as long as it works. And it's working, as you saw. We have lights, which I don't know if you can see them because the lights above here are so bright. But I can see the 3 pumpkins are front flash. I didn't see the back ones because I'm obstructed. And we heard the sound, and the motor was turning. So I'm calling this a win. And I have no idea why it has this switch, unless this switch controlled the sound. I really wish it would say. Let me read the box real fast. I know there's no instructions, but... Now, the box just says, "Can I have this dance? Join in the fun or sit back and watch these costume characters dance to Halloween tunes." So I'm assuming it plays more than one tune. And on the other side of the box it says, "No tricks this Halloween, just treats. Like the fun you and your little spirits have decorating a scary good time. Black cats and pumpkins, witches and goblins, and things that go bump in the night all awaits the enchanting world of Department 56 Villages and their creepy accessories." So, yeah. I have no idea what the switch was for. I mean, I could Google what this thing looks like online and go from there, but honestly, it works. I bought it as a broken piece, and now it's a functional piece. And now we're going to put it back together. So when I said the flat button or flat tops, as you can see, there's a ring around the top of that screw, and this one's a much larger. You might be able to see. That's what normally holds the motors down, especially these 120 volt ones and the 12 volts or 9 volts, respectively. Any of the synchronous motors, because the flange presses on the steel tabs and keeps the motor seated. That screw's too long. It bottomed out, so this is a shorter screw. That's right, and I got another short screw, so I'm going to replace it. I got them in different lengths. I don't know how deep the hole is, so I don't want to crack it by forcing it to make new threads. That's going to hold the motor down. I have it unplugged, but I'm going to remove the white and this yellow wire, and I'm going to get rid of this board. We're going to heat shrink the splice connections. I'm going to get the hot glue gun fired up. I'm going to glue this crap down. That way it's good to go. I don't think I have my little zip ties in here, but I could use a little zip tie to hold these wires into this loop, the other screw hole. But I don't think I have them in here. Oh, come on. So this is a cheap Amazon hot glue gun that I modified from some specs online that fit the DeWalt batteries. And the pins push through into the battery, and the pin walks up inside because the 3D printed plastic housing is failing. But DeWalt doesn't make a hot glue gun yet. Ryobi does, but I got rid of all my Ryobi tools a long time ago, and now I have the yellow tools. And figured, screw it. There's a way to make it work. I'm going to make it work. All right. Also, I need to glue that back on. That's the cover that holds the transformer in. Oh, the zip ties in here. That's really long. Where's my short one? Here's a short one. So a lot of Department 56 does this. They'll have zip ties around different things to hold it. I'm actually going to zip tie it around the column here. That way it's lower so it doesn't interfere with the rotating deck. So, like that. And while I'm waiting for this to heat up, let's see if I can unscrew this fitting so I can glue it into the bottom like it's supposed to be. So, if it's like their other ones, it should be left-handed threads. Oh wow, that's really tight. The, what was it called? The swinging goolies. The cap, a lot of times when you go to unscrew the swinging goolies from the cap, the brass fitting gets caught. And that is what I think has happened here. And then you end up breaking the cap. Because most of these just unscrew. Now, I'm not saying this one's not different, but I'm going to try and see. But you don't want to turn the actual motor. Yeah, there we go. That. And I think the hot glue gun's hot because I see a drip. It's hot, it's just not real hot, but it should be hot enough to start this process. And we're going to need the super glue. Because we got to glue the character on too. I'm running low. There we go. A little dibba dabba do ya. Something to push on. I'm not going to hammer it. I'm just going to use the hammer as a press. I can press that in because it's recessed inside that collar. It's definitely hot since we now got liquid. There we go. Leave that out for the characters. Helps put it on the right way. Beautiful. Nice and liquidy. Probably several hundred degrees. So there's a couple ways to heat shrink wire. You can cut the wire, solder it with the heat shrink slid down on the inside, and you're good to go. The other way is the bend or the TP. I don't know what its correct name is. It's probably not even a correct form. But with the wire folded over, you keep it folded over and slide it down on the down over it. I need to solder that one because it's not soldered, and so I'm going to fire up the soldering iron. This one is soldered. So the wire, you fold the wire over, and then you just slide it on. This might be one size too small. Nope, perfect. I see this a lot in the job I do for splicing, and I've seen it actually on Leamax and other. And then we're just going to heat her up. Keep forgetting I got to do it from the left because the fan, the ceiling fan, blows the air that way. I'm using the screwdriver's weight to hold it in the glue, so that way it's pushed down. If you were wondering why there was a screwdriver handle sitting on that circuit board, it's just there to hold the wire. Or hold the circuit board down while I work on the wire is what I meant to say. And there we go. That should be good. Perfect. All right. Now we're going to test it again. We want to make sure that in the process of doing this, nothing got broken. So I'm going to pull these wires over so they'll fit inside. They're nice and tucked. Out of the way. Wires are connected. You turn her on. Make sure it works. I did unplug it from the wall just to be safe. Lights are flashing. Alright, which way is which? 1, 2. I don't think it matters, actually. Okay. So the groove side goes up. Well, now I know why there was no screws in that motor. It's because it actually goes through here, so that's why the motor is flopping around. So yeah, don't do what I just did. I'll take these back out. So this plate, these two screw holes push the motor into place. So make sure the motor is where it needs to be. And this white wire is too high. Let's get her over. There we go. Down. Okay, so it should be this way. That lines up. The screws are not equidistant apart. That one lines up. That one lines up. That one lines up. Assuming it goes this way, as there's a notch for the motor. There we go. There we go. I do got to replace that one screw that's bad. But the first thing I want to do is screw in the screws that hold the motor down too. That's why they're not as deep, is because it has to go through this thick flange. So I know this motor screw is stripped, so we'll go back into this little container of screws. And it should be this one here. Nope, that's the wrong one. This one. Nope. There we go. Right threads, right length, head slightly fatter. That screw is stripped. Go. There we go. She is screwed down. I would lose the sound and the lights. Apparently the switch does work. So the switch works intermittently. Down all the way. Okay. So this is one thick, heavy piece of resin. I mean, it's heavy. Very surprised. Maybe I'll just put this thing in. Assuming the power comes out the back. And these wires probably tuck up under here. So we can get the characters to slide through. I'll clean up the wires in a minute. I want to see how this thing fits. So that's center. One wire. Of course, it's always... Apparently they taped the bottom on. When they took the glue off, there's tape. to get into the groove. There you go. I like when it listens. So here is the cord holder. There we go. Apparently we got a white wire that came out of the groove because I can see it right here. There's an actual spot for these wires. There we go. Alright, I'm going to hold the base in because it's recessed, so if I let it down it drops below the deck height. It's weird how it intermittently touches the sides. So the button turns on and off the music. Well, it turns it on. Turn that way. We should turn that way. Yeah, there's a spot right here, all the wires get tucked in. The O-rings are replaceable. They are touching, but I don't know why the characters aren't spinning. They keep lifting, they're going above the track. It's pressed in all the way. Screwed down. Alright, one more try. Alright. Looks like that time all the wires went where they're supposed to. Yeah, even on the bottom. Alright, so I gotta put my hand under here again to hold the deck height right. So, I went from a completely broken piece that I have no clue how to repair, since I've never worked on one nor seen the inside of one before, to I'd say mostly functional, like 95% maybe. I'm not sure why this was in there. I don't know what it connects to. I have no clue, but it works without it. The button turns the music back on, so not a clue. If I ever get another one of these, I might take a picture of how it's all wired in. I'm not going to get rid of this. It's going to go into the spare parts bin, but for the moment I'm going to put it up here so it's out of the way. Alright, so I'm going to get this thing hot again, glue the entire bottom on, since I'm not going to put all the masking tape and clear packing tape back on that they had, and I'm going to glue the characters back on, these guys over here. And after that, fire it up in low light and we'll see how she looks. And we'll go from there. So I am going to pause it now, just so you don't have to sit here and wait, since I think this is going to be a very, very long video, probably close to 2 hours. But yeah, so I'll return in just a moment with hopefully fully assembled and somewhat dancing Halloween dance from Department 56. Be right back. Okay, it's back together. Characters are glued on. The bottom's glued in. Everything's glued. So, there's some light because I have a backlight on, but it's not bright enough. That works a little bit better. That's good. Just trying to adjust this lighting here to so if I press the button, so it doesn't turn off the music, but it does stop it from, you can restart it. You can see the pumpkins are flashing. These two are way brighter, but they're a different material. I'm just going to turn it off so you can hear me. These two are brighter, this one's medium, and those are dimmer, and it's the type of material. You can tell these are less translucent than these. These you can see are more translucent up close. I'm going to turn some of these lights back on. So, there we go. I thought my light just burned out the way it flashed. Apparently the switch is going. So, there we go. Get rid of that. Really don't make a difference when the other lights are on. Anyhow, so as far as this goes, I'm not sure exactly what the relay is supposed to do. I don't know if it's supposed to have more than one song. It says holiday tunes, but that doesn't mean anything because it says holiday tunes that you listen to this time of the year. I mean, it could just be a reference to the stereo, radio, so on and so forth. But I probably look it up online just to see what it's supposed to do completely. Maybe it is supposed to play more than one song and we're just stuck with one song, which it is what it is. It went from a non-functional, broken unit that was wired wrong to now a functioning unit that may not be 100%. So that's what I'm saying. I'm going to call this 95%. So you got to peel the bottom out if you have this piece. It's not screwed in. There are screws. Those screws are standoffs, but there's no screws in them. It's just the tips of the screws from the top. Peel the bottom off. Make sure it's unplugged. Check your motor. I told you what the motor was. You can find them on Amazon, and you can contact Happy Holidays Parts or Suntronics out of Florida. They may have the motor because it is a 120 volt motor, and he does carry a lot of those 120 volt synchronous motors. Hopefully that's the only thing that ever breaks in this, because you don't get one like I just got where it's all wired and discombobulated. So the transformer doesn't work like it's supposed to. It says it's supposed to be a 3 volt DC output. I'm getting 6 volts AC, but the rectifier and the load brings it to approximately 3 volts DC. That's the reason the lights work and the music works. Had a broken track. You saw how I fixed the track, scraping the track. It's flexing it and putting solder on it real quick because it's literally a millimeter or less from blob chip, and blob chips are super sensitive to heat. And then once those fail, you're done. So the LEDs are replaceable. You can find flashing LEDs. They're either going to be white or orange or yellow. I'm assuming they're probably white because these actually have some heavy paint on them. And the white will show through the paint better than a yellow or an orange will, because of course the yellow or orange will absorb into the yellow and orange paint. You can rotate these characters like so. So if you take this out, you want the fattest part of the characters inwards. So you can wiggle this out. You can see this and this clear This one doesn't. So when you take it off, you would tip it like that to clear the characters. The Jester was glued on, but he's also screwed on. So I just turned him to where he fits over the glue. I'm not going to glue him back down because he is held on with the screw. As far as the piece, it should unscrew. If it will not unscrew, like that was so hard because it was probably torqued or somebody put some lock thread on it or glue, pry it off with a big screwdriver or something and get the disc off, and then you can use 2 pairs of pliers to break the brass free. The reason you do that is if you just try and turn the brass, and if you turn that synchronous motor backwards, you can break all the internals, and then you have to replace it. So you have to hold the shaft so that the shaft doesn't move. It's like using a double wrench for a nut so you don't twist the bottom nut, jam nutting, and then you break it free. I was going back and forth until I started seeing movement and figure out if it was left or right-handed threads, because the spinning goolies, as an example, are left-handed threads. This is right-handed threads. So the spinning goolies, twisting it to the left tightens it, twisting it to the right loosens it. So it's lefty tighty, righty loosey versus righty tighty, lefty loosey, which is what this one is, which is standard. So depending on how they're pressed, you might have to wiggle it back and forth until you see which way it's moving the most, and then just unscrew it at that point. They should always be pressed into the top when they have that brass knurled collar or ring, threaded nut, whatever you want to call it. But if that's why I didn't put a lot of glue on it. So if you saw, I only put 1, maybe a half a drop in the bottom. That's in case it sticks again. I can pry it and the prying will break the glue free and I can pull it out. If yours is a super tight fit like this was, you don't even have to use the glue. I'm using the glue because I don't know if you have this piece, but it's stored upside down in this box. And with my luck, especially out here when it gets hot, this could just fall straight off and hit the bottom, and maybe that's what happened and that's why these characters are broke off. I don't know. And it's very possible they were broken off when the previous owner of this was disassembling it to try and do whatever he was doing to it, or she. I have no idea. I bought it at a thrift store. So, but this is probably something I'm not going to keep. It doesn't really fit my Halloween motif. I don't have a barnyard style dance. I mean, you could put it in your pumpkin patch, but I don't have anything like that this would blend into. So I'm debating on getting rid of it. If this is something you think I should do in the Halloween giveaway, since it's only the 2nd week of September and we got 6 more weeks till Halloween, comment below. Let me know. Maybe it'll be the final week if it's something that you're willing to put into your display, knowing that it may not be 100%, because I don't know what 100% is on this piece. So if you stuck through this and you got to this end and it's something you're interested in, comment below, and then maybe I'll throw it into the giveaway. If not, it's just going to sit in a box on a shelf until God knows when. So anyhow, this is one of several that I bought from a thrift store. Matter of fact, the pirate house that I gave away as a giveaway, or the pirate style house, that one came from the same thrift store. I bought a shopping cart that was stacked about 6 or 7 feet above the top, and I did it mainly to just repair them, show them how to repair them because they're different pieces, and then I'll probably get rid of them because nothing I bought matches what I do. So, but anyhow, there you go. Department 56 Halloween Dance. I have no idea how old it is because this one is actually not dated, which is strange. But based on its assembly, its cord, how the cord is a thinner style than the new ones, and all that, I'm going to go, this is probably about a decade old. So I'm going to say mid-20 teens, maybe 2012 through 2015. I could be wrong. It could be right. It could be crazy. So, other than that, there you go. Halloween Dance. From in pieces out of the box broken, which all I did when I set it up was check the fuse to see if the fuse was the issue, because a lot of people overlook that on these 120 volt Department 56s. There's a fuse in the plug. It was already hanging in the box, so I just set it on its side. So as the cable was too, I didn't trust it to try and twist it off to the back and maybe have it arc, because again, they weren't heat shrunk, they were just twisted and kind of soldered. and I wasn't sure the voltage going through those wires. I figured it might have been between 4 and 12, not 3, but that's why I want to pop the top of that transformer off. So anyway, thanks for watching. If you stuck through this, God, probably close to 2-hour long video. Now you know what I do when I work on some of these where I'm rebuilding them from scratch. I'm actually working on another one that's right there. I work on it a little bit every night just because it is a full rebuild of the RIP mausoleum from Limax. Everything's wrong with it, and it's now right now about 90% functional. Everything works except for some of the lighting. So outside of my normal day job, I do this stuff in the evening, and this is why sometimes it takes a while to get the videos out because of long pieces like this. And again, if it's something I've already worked on, like the RIP museum, a mausoleum museum, I don't film them. So just to show you, there it is. And I have a couple of videos on that, but that was a broken, non-functional piece that didn't work right, and I've gotten the drawer to work, the door to work, the stair is over there behind it, that's missing. I got this to work, this didn't work, but this light works, these outer two don't, and then one of the two caps, only half the lights work, so I'll probably be working on it later tonight, but I wanted to get something new for everyone out there to see, so that way if you have this piece, it gives you an idea on maybe how to fix it or how to access it to replace the motor, because that's about the only thing outside the LEDs that you're going to be able to replace. So anyhow, till the next one, thanks for watching.